Morning, class.
Morning,
Imperfections in solids. So, does anyone in this class know what is imperfection in solids? Mr. Ankit, can you just...
Crystalline solids are formed by joining large number of small crystals. When the atoms they are arranged in the crystals, they are arranged at fixed distance and they are determined by unit cell parameters. So, when the atoms are arranged, there are defects which are present in crystal lattice. So, these defects are number 1 point defect, number 2 line defect, number 3 volume defect.
Well, that was a good explanation by Ankit. Do you all agree that?
Yes, sir.
Yes, sir.
So now, what are point defects? Today's class will discuss only about the point defects. So point defects are where an atom is missing or is in an irregular place in the lattice structure. Point defects include self-interstitial atoms, interstitial impurity atoms, substitutional atoms and vacancies. So, and there are three types which can be stoichiometric, non-stoichiometric and impurity defects. So is there anyone in this class who can discuss stoichiometric defects? Okay, both of you stand up please. Explain.
It is a type of point defect which does not disturb the stoichiometry of the compound. There are four types of defects. One is vacancy defect, one is interstitial defect, one is Frenkel defect, and one is Schottky defect. So vacancy defect, in this defect, some lattice site are left vacant during the formation of crystal, and this is known as vacancy defect. In vacancy defect, an atom is missing from the atomic site, which result in the decrease in the density of the compound.
Interstitial defects. This defect is observed in non-anionic species. It happens when an atom goes to a place where it isn't supposed to go. What happens is that this increases the density of the substance. Such a defect is known as an interstitial defect.
Schottky defect. Schottky defect is a simple vacancy defect which occurs in the ionic compounds which has cations and anions of similar sizes. For example, AgCl, KCl, AgBr. In this, both cations and anions are missing from the regular places, and the missing cations is equal to missing anions to maintain the electrical neutrality of the ionic compound.
Fresnel defect. This is a vacancy defect. This is observed in some compounds when an ion gets dislocated from the crystal lattice. This is due to the difference created due to the cations and anions. This defect is observed in AgCl and ZnS.
That was a very good explanation by both of you. So now let me tell you the defects like Frenkel defect and Schottky defect, what are the main differences between them. So the defects like Frenkel defect, I can tell you that it is also known as the dislocation effect, and the density of the substance remains unchanged. Well, there is a huge difference in the size of atoms and cations when it happens, and that was about Frenkel. Now coming to the Schottky defect, it reduces the density of the substance and the size of the cations and anions are almost the same. So now we come to the impurity defects. Sandesh, can you just tell me?
Impurity defect. Impurity defect is a type of defect in which an ion of a compound is replaced by ion of other compound. For example, I'll tell you NaCl. NaCl is being displaced into Na positive and Cl minus, in which SrCl2 will get displaced with Na positive and Cl minus. Therefore, Na positive ion will be replaced by two ions of Sr2 positive. This is an impurity defect of NaCl. Thank you.
So now we are left with non-stoichiometric defects. Param, can you just explain a little bit of it?
The defects that arises due to the presence of the constituent particles in non-stoichiometric ratio is known as non-stoichiometric.
Well, Param, you didn't tell us about the types. Palash, can you tell us the types?
Yes, sir. So, first type of non-stoichiometric defect is metal excess defect. Metal excess defect is basically of two types. First type is metal excess due to anionic vacancies. This is basically due to free sites which is left by anions and occupied by the electrons. The hole created when the anions left the site is called, and occupied by the electron is called F center. And basically due to this reason of electron occupying the whole interstitial site, a color is imparted to the compound. An example of this compound is NaCl, KCl, etc.
Many metals show the metal deficiency defect as they have less metals as compared to the ideal stoichiometric proportion. The less proportion of the metals is compensated by the same metals having higher valency. So this type of defect is mostly shown in the transition elements. The one of the most common examples is ferrous oxide. Thank you.
So today we have completed point defects and tomorrow we are going to do line defects. Are you all satisfied with this?
Yes, sir.